皆さんこんにちは。本日は MAC3D オンラインセミナーにお集まりいただきありがとうございます。私、司会を務めさせていただく人体計測営業部の染谷と申します。
私、輸入部の原と申します。よろしくお願いいたします。
営業技術部の増田と申します。よろしくお願いします。
我々が今東京の北青山にいるんですが、最近だんだん暖かくなってきまして、桜の方がほぼ満開になりました。なかなか外出しづらい状況続きますけれども、桜の、力も借りまして、本日良いウェビナーにしたいと思います。よろしくお願いいたします。はい、それでは発表の方に移らさせていただきます。弊社は光学式モーションキャプチャーを20年以上サポートしております。今回モーションアナリシス社から講師としてエミリー・シェーファーさんにお越しいただき、ユーザーの皆様にアメリカでの人間工学やバイオメカニクスのモーションキャプチャーを使った最新事例をご紹介します。それでは発表者のエミリーさんお願いいたします。
Emily, we will start your presentation soon. Would you like to say a few words before it begins?
Sure. Hi, I want to thank everyone that's taken the time to join us for the webinar today. I also want to thank NAC for inviting me to speak on behalf of Motion Analysis. I'm excited to share with you some of the ways in which our customers in North America are using our technology in biomechanics applications. I hope you enjoy the presentation and maybe learn a little something new along the way. I'd like to start by thanking NAC for having me here today to talk on behalf of Motion Analysis about some of the biomechanics applications in which our customers are using our systems in North America. To start, I'd like to introduce myself. I'm Emily Schaefer, and I've worked with Motion Analysis for about 5 years now. I started as a customer support engineer and then moved into biomechanics applications. On a day-to-day basis, I'm working with customers as tech support, addressing any questions or issues that come up. And then I also travel and do installations and trainings on how to use the system. Another part of my job is helping new customers or current customers find solutions to their study questions using motion capture technology. Motion Analysis was founded in 1982 as a global leader in motion capture technology, a distinction we continue to hold today. We focus on developing high-quality motion capture camera systems, as well as the development of a robust software that can address a wide range of needs in various different industries. Our systems measure motion by using cameras and retroreflective passive markers. The markers are attached to a body in the space, and the cameras emit near-IR light, which is reflected back off of the marker for detection by the camera. That information is then compiled to determine a 3D triangulation of each marker in the space. We have a current line of cameras listed on the left of the screen. These cameras address a wide range of needs by offering various different resolutions as well as capture speeds. We also offer Cortex software. Cortex is the backbone of pretty much any application in which you wish to use the system. It offers the ability to integrate with third-party devices, whether that be force plates, EMG, reference video, or some kind of eye tracking hardware. It also offers live and post-process tools, tools for model creation that's used in kinematic and kinetic measurements, live and post-process feedback tools, reporting tools for creating presentations or different graphs, tools for exporting data, as well as creating custom presentations that can be viewed in a standalone software outside of Cortex. The hardware and software that we develop is able to address solutions in various different industries, including video game design, animation, studio broadcasting, augmented and virtual reality, product development, robotics, as well as ergonomics and biomechanics. Within the field of biomechanics, we've worked with several different customers in various different fields. In sports, with those looking at athletic performance and injury prevention, as well as product development at such companies as Under Armour, which you can see pictured on the far right, CCM Hockey, which I'll talk about in a little bit, and Saucony, and many more. We've also worked with customers in the rehabilitation and clinical space in applications such as gait labs, human performance labs, and speech pathology labs. These customers are working with individuals anywhere from children to elderly populations, those that are unimpaired and those with physical disabilities, as well as those interacting with mobility devices. In the ergonomics space, we've worked with many customers. You can see one in the lower left. Those customers evaluating movement of subjects that are interacting in the environment in which they work in an effort to help create a more safe and user-friendly environment. We've also worked with customers measuring animal movement, trying to understand navigational patterns and motor control, as well as neuroplasticity. One of those applications is at the center there, where you can see kind of that rainbow coloring, and that's an example of a bat flying application, and many more beyond these. So moving forward, I'd like to highlight a few different specific customer sites that are kind of unique applications. So I'll move forward and sharing those with you. The first site I'd like to highlight is the Performance Lab at CCM Hockey. CCM Hockey has its origins over 100 years ago and today is the largest hockey equipment manufacturer in the world. Their headquarters is in Montreal, Canada. To help them develop some of their world-class equipment, they have a performance lab. This lab is equipped with 14 motion capture cameras. These are Kestrel cameras made by us, Motion Analysis. They also have an area with artificial ice and high-speed cameras. That area is pictured at the lower image at the upper left. So you can kind of see in that image the Kestrel cameras mounted around the ice. So typically they have the cameras mounted in this space, but they also have the ability to take the cameras down and move them into different sites for mobile captures. So one of those mobile captures is pictured at the right there. Cameras are mounted around the capture space where you see the hockey player at the center of the volume there. On the left-hand side, you see two users sitting at desks in front of computers. One of those users is collecting data on the subject, and the second user is post-processing data. So CCM Hockey has been able to take this system and test various different NHL prospects, professional hockey athletes, as well as college athletes. There are two main categories in which they are using this system at CCM Hockey for both fitting of equipment for subjects as well as in product development. So the first item that they're looking at is hockey sticks. So when they're stick fitting for a subject, they're looking at different parameters that are contributing to how the player is using that stick and determining a best option for the player himself. At the right, you can see the stick is outfitted with several markers, and from this data, they're able to determine a shaft flexion profile, blade stiffness, as well as with puck trajectory and prediction algorithms, they're able to determine a shot accuracy with a given stick. So all of this information is compiled, and the subject is given a stick recommendation by the end of the capture session. During the capture session, they can provide immediate feedback using Cortex. That's pictured at the upper right with some of the custom graphs that they've created. And then they export the data to MATLAB to produce the report down at the lower left. A second application in which they're using the system is in looking at various skates. So again, they can do subject-specific skate fitting to determine what kind of boot flexibility an athlete needs, or vary the distance between the foot and the blade to determine how best the athlete will perform. So in this application, they outfit the lower extremities with markers as well as the skate itself. And from this, they can determine ankle range of motion, ankle angular velocity, foot contact time, stride frequency, and stride length. So in the lower video there, you can see some of the immediate feedback they're getting from Cortex with those two graphs that are created immediately when recording data. So this hockey application shows a unique aspect of the system in that it can be a mobile system. It can be taken down, moved to different sites, set up on tripods, and used in different environments instead of just a stationary lab. It also shows the versatility of the system, that it can be used in a environment that would be considered somewhat highly reflective with ice. You would expect some reflections, and we can accommodate that with some of the settings in the camera system. The next site I'd like to highlight is the University of North Texas Health Science Center and their Human Performance Lab. This is an application in which the system is being used in a rehabilitation setting. This site is using 16 motion capture camera systems, and these are a mix of our Eagle 4 cameras as well as our newer Kestrel cameras. This shows the ability of the system to work with older cameras as well as new. If sites are interested in gradually updating cameras, that is a possibility. This site is unique in that it uses a Karen system made by Motec Medical. This system is a combination of the motion capture system as well as a immersive virtual reality screen or virtual reality environment, as well as a split belt treadmill. So as you can see in the video there's a curved screen that the subject is looking at. The subject in this space feels completely immersed in the environment that's being shown on the screen. The split belt treadmill is force instrumented, so they can gain ground reaction forces that's synchronized with the motion capture data. So from that data, they can determine kinematic and kinetic response to various environments. As you can see there, the treadmill can be inclined or declined. They can also apply different perturbations to the treadmill to force the subject off balance, and then they can determine the kinematic and kinetic response to that perturbation. So this system is typically used in studying Parkinson's disease, and the lab has a great effort toward determining why falls occur in an effort to create rehabilitation programs to prevent fall and thus prevent injury. The next site I'd like to highlight is the Toronto Rehabilitation Institute Labs. This again is a rehabilitation application of the system, but it's a very unique application in that it requires continuous calibration. Continuous calibration is a unique feature offered by Motion Analysis, and this is a feature that requires stationary markers on the floor and walls of a space. These markers allow the camera to back calculate its position as long as the camera is seeing those markers. So if the camera is perturbed or moved or shaken, the camera remains in calibration. And this is especially important so that it continues contributing to tracking marker data even after being moved. So this is incredibly important in the Toronto Rehabilitation Institute labs because these labs are set up into pods, and you can see one of those pods at the left-hand side. That blue box with with the cutout on the side, that's one of their pods. In the cutout, you can see the subject walking at an incline. He's harnessed, and then you can also see the cameras in the background mounted within the pod. So continuous calibration is so important because these pods can be moved and shaken to force the subject off balance. This pod itself is a winter pod. The pod can be altered, the environment in the pod can be altered to simulate a Canadian winter. They can adjust temperatures to sub-zero temperatures, apply snow or ice, as well as high wind conditions. The goal of this lab is to study slips and falls as they relate to winter weather conditions without exposing the subject to the high risk of that environment in the real world. This is especially important in understanding how elderly and disabled populations maneuver in winter conditions, as these populations are often confined at home during the winter months. This lab is also looking at testing winter weather and footwear, as well as mobility aids such as wheelchairs or walkers, and to see how they hold up in winter. Similar to the winter lab at Toronto Rehabilitation Institute, the stair lab is also equipped with motion analysis cameras. This lab is also in a pod environment. The equipment in this lab can be adjusted or modified for a given study. The equipment includes a fully instrumented staircase on which treads can be changed to simulate user interaction with different surfaces. This might include changing the material of the stairs as well as markings or coloring. Ground reaction force and handrail force are measured in conjunction with the motion capture cameras, and this is taken from force plates instrumented within the stairs, as well as load cells in the handrail. The goal of this lab is to better understand why people fall on stairs and how these stairs can be modified to prevent fall. This research has a goal of obtaining evidence for improving building codes as well as construction standards to increase safety and usability of stairs. Understanding behavior of users on the stairs is also of interest, as this can be used in the development of personalized rehabilitation programs for those individuals at high risk of fall. The final application that I'd like to share is kind of in the ergonomic space. This was something that we put together in our offices as a proof of concept study for a prospective customer. The goal of this application was to evaluate pen angle and vertical and horizontal movement of a utensil relative to its writing surface. So while several of the previous applications that I mentioned used many cameras, a lot of them tracking full body motion, this is a very small application. This application used only 4 Kestrel 300 cameras, and they were spaced in kind of a semicircle around the subject. To gain the data that we needed, we outfitted the pencil with markers as well as the writing surface. This company was interested in better understanding how the utensil impacted writing style, and they wanted to be able to measure the angles of the pencil as well as the horizontal and vertical movement of the utensil relative to the writing surface. So I've covered a few applications in which our system is being used in the biomechanics space. There are many, many more that we could continue to talk about, but at this point, I'd like to hand it back to Knack to address any questions that we have.
はい、エミリーさんありがとうございました。それでは質問の方に移らさせていただきます。質問の1つ目ですが、以前スケートリンクで計測をした際に反射によるノイズがすごかったです。 計測の際にはどのようなことに気をつけるときれいなデータが取れますかという質問をいただきました。
Okay, so the first question. We've tried the measurement at the skate rink before and have struggled with highly reflect with ice. Is there any way to prevent the reflection from affecting accurate data?
Yeah, so there are a few options within the Cortex software that'll help with reducing the amount of reflections in the space. So CCM hockey has been successful capturing on the ice with a fairly high frame rate as well as a high shutter speed. The frame rates that they're using are around 240 to 500 frames per second. Thresholds can also be increased in an attempt to reduce the amount of reflections off of the ice that are viewed as centroids. The team at CCM has gotten very comfortable with being able to adjust those thresholds during and before capture sessions to make sure that the quality of data is the best they can get. They've also gotten comfortable with masking certain highly reflective areas that they can afford to lose during a capture. So two additional features that may help are the asymmetry limit as well as the shape analysis that's available when using grayscale cameras. So the asymmetry limit compares the height to width in pixels of a given area of bright pixels. And then the shape analysis looks at the roundness of that collection of pixels. So by tightening these features, we can allow you to continue to track those spherical markers while removing centroids that are less symmetric and less round in the space.
はい、回答ありがとうございました。次、2つ目の質問ですね。読みますね。頸部、没入型のディスプレイによるリハビリ応用についてですが、リアルタイムで動力学計算をする機能は Cortex に搭載されていますか？ある場合、どのオプションソフトを使うとリアルタイム動力学計算ができるか教えてくださいという質問をいただきました。ではこちらも回答の方お願いします。
はい。Emily, let's go to the next question. Regarding the rehabilitation site with CAPE, does the Cortex have the ability of dynamics calculation in real time? If so, which optional software allows you to make it?
Cortex does have features used in real-time dynamics calculations. To successfully calculate real-time dynamics, a robust identifying template marker set, a skeleton, and a mass model need to be defined in the marker set prior to collection. So once that has been done, Cortex can identify markers and calculate dynamics measurements in real time. Kinematics and kinetics can be calculated on a user-defined marker set using Skeleton Builder and KinTools licenses.
はい、ありがとうございました。
ありがとうございます。英語でいただいております。
はい。
Emily, we have a new question that comes up. He already gave us the English. So he asking, all the reference videos are indoors, but is it possible to use them outdoors?
Yes, certain of our cameras can be used outdoors. The best option for outdoor tracking would be the Raptor 12 cameras. Similar settings to capturing on ice are recommended for outdoor capture, like higher frame rates, higher shutter speeds, increased thresholds. But yes, the cameras can be used outdoors.
ありがとうございます。じゃあ次よろしいですか？
はい。Emily, we have one more question. It is about continuous calibration. Could you introduce us an example of application with that function has advantage?
Continuous calibration would be advantageous in a scenario where you're your mounting system isn't stationary at all times. So like the pod example, the cameras mounted inside of the pod move with the pod. So they can move out of calibration. So continuous calibration is required. We've had other customers with the cameras kind of on a strut system that itself moves. So in that scenario, we would need continuous calibration to make sure that the cameras remain in calibration and are able to track other items in the volume.
回答の方ありがとうございました。こちらもちょっと英語でいただいたので、そうですね。回答の方原さんからお願いします。
Emily, I think it's going to be the really last question. Is it possible to measure 6 degrees of freedom for high-speed rotation and high-speed flying objects?
Yes, it is possible to measure 6 degrees of freedom of an object, including a flying object. Using a prop marker set would likely be the best option for tracking if the object is a rigid body.
はい、ご質問、ご回答ありがとうございました。ちょっと最後の方になってきまして、ちょっとお知らせをしたいと思っております。MAC3D の基幹ソフトの Cortex について、アップデートが、あるという情報を少しモーションアナリスト社からいただいてますので、少しご紹介いたします。増田さん、お願いいたします。
はい。新しい Cortex の、Cortex 9なんですが、基本機能のブラッシュアップに力を入れて、ユーザーの使いやすさを、追求しています。主な機能アップとしては、キャリブレーション機能の向上、あとカメラマスクの使い勝手の向上、あとカメラがカバーする、キャプチャーボリュームの、ヒートマップ表示、あと最後に、複数マーカーからなる先ほど、質問で答えていたプロップを使った、保管処理が追加されています。でこちらCortex 9ただいまですね、ベータテストをしていますので、夏前までに、リリースされるという予定をしております。
はい、ありがとうございました。また詳細に関しては、改めて皆様にご紹介する機会をいただきたいなと思っております。はい、では、本当に最後ですね。せっかくですね、エミリーさんから一言挨拶をいただきたいなと思います。
はい。Emily, we are now at the end of the webinar. Please say a few words and then we will finish the webinar today.
Thank you to everyone that stuck with us through this webinar, and thank you for the questions. We would be happy to continue the conversation, and if you have any additional questions, please feel free to reach out to me or to one of the representatives at NAC.
はい、ありがとうございました。では本日これで、MAC3D オンラインセミナーを終了とさせていただきます。ありがとうございました。では、さようなら。
さようなら。
Thank you. Thank you.